Welcome everybody to this Iliad webinar. It's one of the webinars that we are organizing in the Iliad Hackathon this summer. My name is Bente Lilja. You to Iliad. Most of you know already about it. I will be very targeted this time, and then we start directly on the program. We are very much interested in your questions and feedback, so please write questions and comments in the chat. And mute yourself while you are not speaking. We take questions and well, maybe we can also take questions directly this time because we have only two presenters. And if there are very detailed questions to the architecture, I believe we can allow some very factual questions then. And then when you think about more questions and comments later, we could do that after the second presentation. So with that, I will start to show you the simple agenda and introduce you to the speakers. And this will be recorded as we normally do, of course. So today we have a very simple agenda. The topic is introduction to the open data platform architecture, from architecture to actually using features. And first we will have a short introduction, as I said. Then we dive into the architecture, the Ocean Data Platform architecture, and Thomas Lee Fredriksen from Hub Ocean will do that presentation. And our own Tom Red from also Hub Ocean will give us some examples in using the Ocean Data Platform, and of course, the discussion. So just to give you, to start, this is a Iliad digital twins of the Ocean project that we are talking about. Iliad is based on a federated system approach. We are both using existing data and resources, as well as adding new data via sensors and citizen science, and also new foundational resources. And this is what you see now on the screen is a very simple way of showing an overall architecture, if you like. On the left-hand side, you see that there are, the Iliad infrastructures is composed then of a federated system. So the Ocean Data Platform is one of several systems that we are using. I would say then that today, when we are diving into the Ocean Data Platform from Hub Ocean, we are moving, in between the data lake and engine, as you can see here inside the overall architecture of Iliad. And for each of our twins, the same structure is applied. So this is a generic it's really a generic. So no matter what thematic or local twin you are building, this is the same structure that is being used. And the Ocean Data Platform is what we are going to visit today and learn about more in detail today. And then I was doing something I should not have done, because I want to introduce you to, well, me. My name is Bente Lilja, as I said. I'm one of the partners in Iliad. I'm the innovation manager, and I'm working a lot on data management, both in Iliad and also globally. But Thomas Lee Fredriksen, he is a lead solution architect at Hub Ocean, and he has been instrumental in designing the architecture of the Ocean Data Platform. So we are very lucky to have you here with us today, Thomas. So please start your presentation. The floor is yours.
All right, thank you. I'm going to share my screen. All right. Thank you all for having me. My name is Thomas Lee Fredriksen. I'm the lead solution architect with Hub Ocean. We're currently working on an API-centric approach to data sharing. Our vision is to become the world's ocean data collaboration hub, and also advancing both ocean health and wealth. Hub Ocean itself is a non-profit foundation. We're founded by the Norwegian Aker Group and the World Economic Forum. We're supporting the United Nations Decade for Ocean Science and leading the Ocean Data Coalition in partnership with Microsoft. And of course, we're operating the Ocean Data Platform. We're a trusted partner to many major organizations in the large segments of society, both industry, government, and science. And we're aiming to be addressing the ocean emergency, especially in regards to climate change. So with this audience, I'm sure that a lot of people is very familiar with the problem that we're facing with marine pollutions and overfishing and ocean warming and acidification, hypoxia. And we believe that a data-centric approach is going to be a big part of solving these challenges. Yeah, we will be. Our strategy is to map and manage using science-based ocean management systems, focusing on renewable energy and sustainable foods, but also green transportation, sustainable investments. So a bit of the background. In the computing, and especially scientific computing, we have seen some very, very large advancements in the past few years, where we've gone from room-sized supercomputers down to small laptops that can do intense computational tasks. And we also have modern frameworks that make this job a lot easier, from the emergence of the Jupyter ecosystem to TensorFlow and other machine learning frameworks, and more recently ChatGPT. Scientists obviously want to spend time on science, and in recent estimates, they're estimated 40% of a scientist's time, or a data scientist's time, is spent on data wrangling tasks. This also includes organizations that have very good data science environments. So realistically, you can expect the median value to be a lot higher than 40%. The data volume of especially ocean scientific data is also an obstacle for a lot of research. Personal laptops are not good enough for the large volumes of data that we are facing. And operating on-premise supercomputers is also a very complex task. And finally, citizen science is an emerging trend. And we want to empower private individual citizens who are passionate about ocean science to share their findings in a common platform. Yeah. Right. A little bit about FAIR. FAIR is an acronym for Findable, Accessible, and Interoperable, Reusable, and stand as pillars for data sharing. And we have condensed the FAIR principles into some sort of guidestones for making this data platform. We will try to leverage metadata, but at the same time also borrow good ideas from others instead of reinventing the wheel. We wish to cater to users and provide solutions that solve user problems instead of our problems, and shape a technology stack to provide solutions to both low-code, no-code users and advanced users as well. And we want to be as open source as possible and rely on established frameworks and methodologies. Once again, borrow instead of building our own, and share our work with the world. And of course, being the ocean geospatial is very important for, and will be native to this data platform. Right, the Ocean Data Platform, the one-stop shop for the ocean. The data platform is built on 3 pillars: data, cataloging, and compute. Data being the data sets themselves, be it temperature measurements from the ocean, or taxonomy information, or occurrence data, or what have you. Cataloging is basically providing an index or a search or way to discover and consuming these data sets, and compute, a framework or tool set to allow users to efficiently consume this data, even in resource-constrained environments. We are heavily inspired by Data Mesh, which is an enterprise-focused data or strategy, you could say. And it focuses on what they call the Data Mesh quantum, that separates data sets into domains and exposes defined ways of consuming that data as a product. We have an API-centric architecture where data scientists and developers will be accessing the API directly, while also providing services such as data science, sandboxes, dashboards, and maps for low-code and no-code users. Everything is hosted in the cloud using Azure. Yep. All right. Some sample use cases relevant for industry. Our platform focuses on enabling data sharing for both industry and scientific users, and also citizens. But for the industry, some sample use cases that we currently have running in our platform is an environmental impact assessment tool for potential site locations. We have a CO2 emissions estimator for ship voyages, time spent in marine protected areas, and ocean financing, environmental risk assessments when evaluating new investments. When tackling the challenge of building an ocean data platform, we started by considering the 4 V's of big data. The volume being the amount of data, and being the ocean, there's lots of data, but also the variety, with the number of data formats being very high, and very different standards of operating across all disciplines that operate in the ocean. This is a very challenging task to handle. The quality of the data is also something to be solved. While we see that the velocity of the incoming data is not as high yet, due to the nature of our platform being a data sharing platform. We have condensed ocean data into 6 primary data types, being physical oceanography and chemical oceanography. This relates to temperature, salinity, oxygen, pH, what have you. Geological oceanography, such as bathymetry and sediments. Biological oceanography, like phytoplankton. Marine biology, such as biodiversity and occurrence data. And human activity, and everything that we humans do in the ocean, such as setting up borders, wind farms, platforms, aquacultures, anything human. This then is condensed to some data categories. The primary one being tabular data, tables. Gridded data, which are multidimensional arrays. This can include weather information, climate models, interpolated maps. Rasterized data, satellite imagery, and land cover maps, video and audio, and point clouds, such as 3D scanning and mapping. The way that we model the data is by first defining a sort of an atomic type that contains the data. We call this the data set. This can be a table, or it can be a collection of files, or a gridded data set, multidimensional array. And then we group these into collections. So data sets that belong together go into a collection. And then finally, in order to enhance search and discoverability, but also help with reporting, we have an object called observables, which are essentially aggregates that observe either a data collection or a data set. This can be, for example, geometric coverage, value ranges of a table, for example, which temperature ranges have been measured, other statistical measurements on a data set. It can also be quality assessments, timeliness, and other things that you can observe from a data set. Next, we needed to figure out what kind of metadata do we need to add to this atomic type, the data set. First of all, which class of data are we talking about? So our data set is either tabular, gridded, or a collection of files. Who is the maintainer? How should this data set be cited? Where do we find documentation about this data set? What is the licensing of this data set, and how to aid discoverability of this data set, how to help others find it. In addition, we have borrowed something from Microsoft's common data model. This is called something called attributes and traits. It's an umbrella term for. We created an umbrella called the dataset attribute, which can refer to either a data table column or a grid dimension or something equivalent for other data types. And then we assign traits to these attributes, for example, which unit it is measured in, exactly what is measured, what kind of currency has been used if we're talking about financial data, coordinate reference systems, which medium has been measured. For observables, for example, aggregates, we have column statistics for tables, averages, variance, min-max values, coverage values, and geometric aggregates such as bounding boxes and circumference. We could also talk about stuff like data health, for example, accuracy of an attribute, how complete an attribute is, how consistent it is, and its validity. Finally, an upcoming term for data contracts. This is a formal agreement outlining the structure, format, and rules and guarantees of how to use a data product or data collection. Basically, it is a guarantee from the maintainer of a data set or data collection about how this data set should be consumed. For example, that a string column that represents, for example, a small DNA sequence should always follow a given standard, that dates and times are represented in a certain way, that data updates happens at a certain frequency. And this helps to reduce the uncertainty by eliminating errors in understanding. The way that we will do this is by using observables to provide the metrics, and the data contract will then set a validity values or acceptable values on these observables, and then basically assert whether or not these are held. In software engineering principles, these can be seen as equivalents of service level objectives. And if this becomes like a legal contractual obligation, then there would be service level agreements. A simple use case Consider a diving expedition. We have a group of divers who are investigating a coral reef, for example. They bring cameras and sensors, and they take photos of fish. In this case, we create a single collection for the diving expedition, and a data set consisting the photos of actual fish, and each photo is decorated with when it was taken and its geolocation. And with it, we have an observable saying when the time range of the expedition or the photos, and the geometric coverage of the photos. And similarly for measurements, if we say that the divers brought temperature sensors with them on this expedition, each measurement is also tagged with a timestamp and geolocation, and the observable would also provide the temperature ranges that were measured and the time range, as well as the geometric coverage of this as well. And then finally, when the divers come home and they look at the pictures, they create a table of the identified species of fish that was observed during this expedition, and this is stored as a tabular data set in the platform. From the user perspective and the data user journey, the user will search for new data by geographic region, unit, maintainer, or anything that's relevant. The user will consume and process the data either directly on their own hardware or using our Jupyter Notebook service. We call the ODP service, ODP workspaces, and then share the results by defining new derivative data products. And then finally, a little bit about compatibility and especially Stack. So we're seeing that we have the types with data set and data collection and and observables in Stack, which is a standard for providing common structure of describing cataloging for spatiotemporal assets. It's an open specification. It's well used. It's basically a full ecosystem, including software and tools. They provide API servers, SDKs, CLI tools, browsers, and it's very extensible with a core standard and community extensions such as raster and time series and data cubes. In Stack, you have catalogs being at the top of the hierarchy, and then collections as being sort of a decorated catalog. And then within collections and catalogs, you will have items, which are individual data assets. And these are described in GeoJSON. The ODP is easily mapped to Stack, where catalog and collections are what we call data collections. And together with observables, they can basically describe a Stack collection. And the same is true for Stack items, where data sets together with observables can describe a Stack item. Right, that was everything from me. Thank you.
Thank you very much, Thomas. It looks very impressive, and we are looking forward to see some examples of it, of the use also. But before that, if there are any burning questions now to Thomas that immediately can ask him, please raise your hand. If I can see the no, I don't see anybody raising their hands. No. Okay, then we will see if you warm up a little bit more when we are coming to the discussion part. While you were speaking, Thomas, I was posting a poll just to check if the audience here were familiar with the Ocean Data Platform, even though it's very new, of course. It's I asked if they were familiar with the Ocean Data Platform. And you see here that we have a mix of test users. Somebody have heard about it, and for many, it's the first time. So just so you know a little bit about the audience. So thank you very much for participating in the poll. We try to engage with you and get to know you a little bit better in order to create also a community here. So thank you very much. And now we are moving on to our next speaker. And you will be able to stay on, right, Thomas, to
Yes,
ask
yes,
a
of
question?
course.
Yes. Wonderful, wonderful. So now I will introduce our next speaker. Many of you know him, Tom Red, also from HubOcean. He is the Ocean Governance Manager at HubOcean, and he leads the activities related to ocean restoration and governance. And he is responsible for the involvement in European activities, and particularly, of course, in Iliad Digital Twins of the Ocean. So Tom, the floor is yours.
Thanks, Bente. Yeah, perhaps we shouldn't have chosen two of staff members from HubOcean with the same name for the webinar. But here we are. I did contemplate calling the webinar Tom, Your Guides to Navigating Ocean Data Platform, but I decided against it. It was a bit too cliche. So I'm going to try and do justice to Thomas's presentation describing all of the concepts and the architectural choices behind building the Ocean Data Platform by showing what the platform looks like today and how it can be used, some of the functionality and features. What I probably won't do is talk about sort of some of the upcoming features that will be coming along, because I really wanted to focus this on, what's there at the moment. But bear in mind, we're in a very active development and we add features all the time. So yeah, and we also welcome feedback from our test users and trial users to try and help build this platform as a resource for people to use and use it in the way that they want to use it. So this is the landing page when you first, I guess you can see my screen. This is the landing page when you first sign into the Ocean Data Platform. So you have all of the main functionality sort of right there in front of you. I'm going to start with the data catalog, which Thomas talked about as one of the three components. So here, of course, we have a list of the data collections which are available at the moment in the catalog. It's not the most extensive catalog, but what we've tried to do as we're just opening it up is to sort of have a few like representative examples of different types of data that you might find in the platform eventually. We at HubOcean have quite a strong focus on industrial data sharing. So that's the example that I wanted to show today. So this is an example of a company that came to us that wanted to share some data that they've collected on the ocean from Brazil, and they hadn't found a good place to do it, or hadn't really found somewhere where they could share that data. And because that's one of our mandates is to promote industrial data sharing, we said, sure. So they actually sent us a bunch of files from CTD profiles to ADCP measurements and marine and mammal turtle observations. The files that they sent us were all in lots of different formats, so lots of Excel files, quite a few PDF files and things like this. So our team worked on, and this is kind of going to talk a little bit about the sort of the transformation process that we do with some data, especially industrial data, is to transform, for example, these PDFs into tables which are a lot easier to start to work with and interpret from a scientific perspective. So this is a collection, as I say, of marine mammal and turtle observations from the coast of Brazil. You can see here, this is now an example of a data set within the catalog. You have a lot of details describing what's in the data. You have tags, who it's managed by, how to get in contact with that person. You also have a sample of the data. So this is what it looks like. And, you can even sort of look and see where individual data points are from the sample. You can also sort of see where the geographic range of the data is as well. So now you might want to get working with that data, and there are two ways of doing that. You can download it as a CSV file. So if you wanted to just get going in your sort of even in Excel, you can do that. But you can also access it through our APIs through the unique identifier, and I'll come on to that in a little bit. So each of our data sets have a unique identifier, and that's kind of going to be important in the next part of my presentation. Going back to the dashboard, this is our public catalog. So then I wanted to talk a little bit about the private data space. So this is what we call my data. So here you can create your own data collections, and these are private to you, so only you have access to them. So I did start working on an Iliad example with jellyfish, but I ran out of time to do that. But I just wanted to show that, you can create a new data collection, call it whatever you want, and then you can create a data set. And this mirrors the same structure as our public facing catalog. And so here's an example that I've been working on over some time, where I've been collecting data on sensitive areas off the coast of Brazil, with the idea of combining it with what's publicly available through our front-facing catalog. So that's the uploading data, and of course, sort of going back into that example, you can of course see everything looks the same. You can still do the same kind of thing of looking at the data in the same way, whether it's in your public-facing or whether it's in the front-facing catalog. Now I wanted to show you the workspaces. So this is where you start to go into the computer environment. So Thomas mentioned that this is a Jupyter Hub environment. I can't really actually see, my Zoom is blocking my, oh, there we go, I've got it now. Yeah, so a couple of things that I wanted to share, which I can't easily do now. Yeah, so let me just open up the file that I wanted to show today. Yeah, so this is just the, I've got a collaborative session ongoing. Never do a live demo, that's what they say. I might have to I'm just gonna minimize my screen, which I don't know how to do I might just have to stop sharing and reshare. Yeah. This is one of these classic examples of why you never do a live demo, because now it's going to kick me out of the platform.
We can handle it, Tom. We can handle it.
Yeah, sure. So I'm just going to try restarting my workspace. One of the features that we've just added to the platform is the ability to collaborate, and it's still in a beta mode at the moment. So that's the ability to work on, for two users to work on the same workspace at the same time. And I did that before testing it with Thomas, and I probably shouldn't, but now I think I fixed it. So yeah, so this is just what I wanted to show you, sort of an example of like how you could use the connecting to the API and start playing around with some data. So this is a notebook example that I've been working on. You see here I'm getting the unique identifier from the catalog. You can query that data. So I'm looking specifically for humpback whales. You get a selection, you get the data here. You can of course then start to visualize it, and so this is the data that we were given by PGS on whale observations. And then you can combine that with other data. So this is again pulling through the API, but this time this is from my private data collection. So if I was to share this notebook with somebody else, they wouldn't be able to access this data. We are working on the sort of, we are aware, of course, that people would like to be able to share it with collaborators, and that's on our roadmap. But at the moment, that's not possible. But it does mean that you can have a private space to work with data without anybody else having access to it. So this sort of workbook now shows that you can then see, OBIS has some fantastic, well, a lot of data, but the PGS data supplements that quite nicely with some unique areas where humpback whales are sighted, which wasn't visible through the OBIS data collection. And of course, you can combine it with other data types. So this is data from the Allen Coral Atlas, which is a global map of coral reef coverage. And in the last cell that I have here, I have sort of just showed where the coral reefs and humpback whales kind of overlap in this area off the coast of Brazil. And of course, once you've created sort of these kind of more advanced data products and things, you can re-upload them or re-ingest them into the platform as new data sets. And that's kind of the idea of platform, is that you can work with it and you can then re-ingest it and create new products. You can, of course, also access data from outside of the Ocean Data Platform. So this is just an example that I got from the Microsoft Planetary Computer, which uses the Stack API, as Thomas mentioned, the sort of similarities. And so this is just to sort of show that you can quite quickly and easily get going with data from other places and bring it in. Yeah, so that's kind of like my presentation. There's quite an extensive documentation on using the platform that we've been working on over the last months. So that's a sort of good place to get started. We're also working on example notebooks to sort of help people get going with using the API and things like that. And so we have quite an active GitHub repository where we're constantly adding new example notebooks, and of course sort of supporting people in using the platform as we're sort of just opening up now. As part of the Iliad Hackathon, we want to make the platform available to any teams that are interested in testing it out and trying the different features, and there to support you in doing that. And so, of course, if there are any people that are interested in joining that trial, then you're very welcome to join. I think I've already asked, but I can ask again if you'd like to give access. We'll give access throughout the life cycle of the hackathon. So with that, I think I will stop my presentation and say thank you for listening in, and happy to take any questions.
Thank you very much, Tom. Now we saw both an overview of the Ocean Data Platform architecture and then some concrete use cases. Any questions? Now I was a little bit late with my poll, but you know, it's an open question that you you invited people, Tom, to use it, and now we are getting a preliminary answer, I would guess. And as it's alive, this poll, I will shortly publish it. So please put your questions, answer into the poll, and other questions and comments for that matter are more than welcome now. So you can raise your hand and we can give you the floor to ask the question, or you can simply write it in the chat, as you please. James. Hi, James. You are muted. Have to unmute yourself.
Hi, guys. Thanks a lot for the presentation. Super interesting. I'm an ex-crew member with Schmidt Ocean, so I've been on research vessels, surveying, collecting data, this kind of thing. I'm now leaning more into machine learning and AI, studying with MIT, and I'm very much keen to like move more in this direction. And I'm very passionate about open sharing of information, and really like I've been following Hub Ocean and this thing since COP28 when I was first introduced to it. Super interested in the organization. I just wanted, I'm interested in using the tool, contributing to the tool, this kind of thing as time goes by. I just wondered, my question was, how are you integrating with publicly available data sets that are already in existence? Obviously, there's a lot out there. JEBCO is one that springs to mind. And then, what's the kind of roadmap going forward for how you become the one-stop shop for ocean data when there's a lot of repositories already out there? What's the approach? The second part of the question is what's the approach to unlocking private data that's perhaps held by some some of the larger sort of survey and oil and gas organizations that perhaps hold a lot of seabed information and this kind of thing that's maybe not publicly available right now.
So Tom, do you want to?
I'd suggest maybe Thomas, you could answer the first question and I could answer the second question. But great questions, James. Thanks.
Yes, definitely. So just a comment to what you said about there being many data repositories out there. That is actually one of the things that we're trying to address, because each repository tries to do it in a different way. So we're trying to collect these repositories in a central place and provide a universal way of consuming this data. And this is true for, say, gridded as well, with the bathymetry as well. Being a gridded data set is an upcoming thing on our roadmap, but we will expose stuff like GateCo through our platform, re-ingested and fully decorated, using our APIs essentially, together with many other things that also is exposed in the same way, making them much easier to join together. And that's kind of the secret sauce that we're going for.
So before you are answering the second part, Tom, just to Thomas, when you say collecting the repository, you are meaning not actually putting all the repositories in one repository, right? You are talking about a federated system and connecting repositories.
Initially,
yeah.
Initially, we're collecting into a central repository. We're gathering repositories together in a common place. But yes, the federated thing is also on our roadmap in order to, once again, expose the data in a uniform way, so that we don't have to relearn all of these different repositories in order to consume them.
Yeah. And just the point about the sort of the catalog as it is at the moment, it's kind of, as I say, representative of sort of different data types that we're sort of interested in handling at the moment, and that's why you sort of saw EMODnet and you know, I think we previously have ingested World Ocean Database just to sort of show that, you know, that there can be an added value of having it also in a different place. But of course, like, we work very closely with all of these other data repositories, and we have quite active ongoing collaborations with them as well. So we definitely don't just sort of hoover up data and then, you know, publicly make it available again. And you know, there's way more data in the world than one platform could handle, I'm sure. So and that's, as Thomas says, that's kind of on our roadmap to sort of like figure out how we can sort of do that integration. On the second question around industrial data sharing, so this is something that's been like a strong focus of our foundation since we've started, and what we've found is there's usually a strong willingness from companies, especially at a senior level, to share data, and especially when it's not competitive data. What we've found in practice is, you know, reluctance and hesitancy to put much resources into actually doing the work that's needed to share that data. And so actually with the PGS example that I showed, they kind of just handed us a hard drive and said, here you go, this is what we have. And it was files in lots of different formats, and yes, and then it was on us to do the work of transforming it into something that's a bit more usable for a user. And so we're trying to figure out exactly like what our role would be in sort of like being the middle ground between I guess companies that kind of are willing to share but just not really willing to invest a huge amount of resources into doing it, but they have to invest something, right? And then sort of we can do something in transforming that data into something that's more usable and more useful, but then eventually thinking about, you know, how can that data go into other repositories, like the marine and mammal one, which I'm really interested in, is, you know, how can that then flow into Obis, as an example, because it doesn't make sense for it to just be on our platform when that data would also have a natural home in Obis as well. And showing the companies the value of sharing that data and how it contributes to the sort of the global coverage of biodiversity data is something that they really like to see, like, once it's done. You know, that's why I actually showed that picture of showing where the data from PGS kind of complements data from Obis, because that sends a really strong message back to the company that there is a value in sharing. Because a lot of the time, that's kind of the issue. It's like, yeah, we could share data, but why would we? It's just, we just have to collect it because we're told we have to collect it. And why is it useful for anybody else? And so by showing people that it's useful, it's kind of like, oh, okay, I get it now. I can see why I would want to do that and how that can be valuable to other people.
Yeah. I'll put on a slightly different hat. GEO, the Group on Earth Observation, which is working on making, which is really a federated system of systems where, you know, it's a governmental organization with participating organizations such as, well, indirectly ODIS, the IOC. So what we are doing there is like the view is that those who are collecting the data are the experts, the data providers. We want to maintain that sovereignty in a way, but GEO is all about open data sharing. So open data sharing by default, but across then the federated system of systems. Now, what is particular here, I think, if I may, you know, what is the ocean data platform from HubOcean here is actually facilitating by when you are collecting different repositories and making them more unified, is part of making a data lake for more demanding processing. So, and in Iliad, we have, I can share the, now, unfortunately, I don't think I have the data. You see here the data lakes. There are, well, there are data lakes, there are external data lakes. So editor will be like when you have a metocean and you really want to do a huge processing of the world ocean, say. Sometimes you also want to have, you need data lakes on very local or thematic twins. And this is what we are doing here in Iliad. And HubOcean is one platform, right, Tom and Thomas, that facilitate this. So that's one of the technology or infrastructure we are using for this particular part. Coming in with the industry data that sometimes that you want to be, not only industry, by the way, sometimes you want to restrict access to some data, even in open data sharing policies. And that's where the data spaces technology is offering a solution. And I guess you are also creating or facilitating a data spaces technology, Tom and Thomas. I don't know if you want to comment on that.
Thomas, did you want to answer that one?
I'm sorry, my connection blipped out the last 2 seconds of that question. What was that?
It was about the sort of the data space concept and how we sort of think about it from ODP perspective.
Yeah. Trying to formulate this in a good way, but we sort of share a view with Ocean Info Hub in that the data space and especially the data cataloging thing is expressed as a knowledge graph, and we also wish to take it a step further by decorating this knowledge graph with contents of certain kinds of data sets and making them even more discoverable. So we are very interested in exploring semantic web technologies in order to enable this.
Yeah, and the access point, who has access to these data, that, I mean, this control over its its sovereignty and giving and granting access to a selection of users. That's one of the things that we see is necessary, both for commercial and all security in some instances. I don't know, James, if I come back to you, so you said you were on vessels and you were doing typically campaign kind of data collection. Is that what you said?
Yeah, it was sort of mission-based month-long cruises and this kind of data collection, whether it's through oceanography equipment or actually survey data, with the bathymetric data, this kind of thing. So yeah.
And some of it was for a specific contractor, or was it scientific use? What type of?
Yeah, always visiting scientific teams. So it was with Schmidt Ocean Institute. So it would always be a science party from an institution, the university, or something else. So it was always data for public consumption. So essentially, it would go to repositories rather than be held in a private sense.
Yeah, and of course, for James's reference, you know, we obviously work really closely with RevOcean, our sister initiative that's building a research vessel that's very similar to Schmidt. So that's kind of interesting that I'll reach out to you separately and we can talk about sort of your experiences from sort of vessel side of things and how we can sort of like bring data onto a platform like ours.
Thanks. Yeah, I really appreciate that. That was my sort of offshore part of my career, and I'm sort of moving more into the data side now from a shoreside remote point of view, and I really see that as like my passion piece area. But the RevOcean project has been a really interesting one to follow as well. And when I realized you guys were both connected, it sort of made a lot of sense, you know.
Yeah.
So that's
Cool.
quite a cool partnership to keep an eye on.
Nice.
So you can be a part of, I guess you can be a part of our hackathon then and get to play with the HubOcean, the platform, right, Tom? We can include him in one of the teams.
Yeah, for sure. Yeah. I'll reach out to you, James, and figure out something that we do.
Yeah.
Thanks. Amazing.
So more questions. Don't be shy. While you are putting your hand towards raise your hand, I will share the results. So Tom and Thomas, here you get the results of the questions. Are you considering using the ocean data platform? Yes, for sure. Many are confirming their interest. And the second largest is considering using it. And some are sitting on the fence. So I think that was a positive response. So we have interested parties here.
Yeah, that's wonderful. It's nice to see
Yeah.
that he said no.
Exactly. It could have been a valid reason, huh? But
Oh yeah, no, absolutely. Yeah, great.
Yeah. So any more questions? Any other comments? I have something on my list, but I can wait until people are. You were so crystal clear. They are just ready to jump on the platform and start to play with it. Now, I have a question concerning the stack, and this will not be a surprise for you, Tom. The combination of stack and the JSON LD, you know, the other way of the other way of presenting data. How is that? So Thomas, this is probably for you. Have you been considering, you know, the interoperability between these two ways of organizing data?
Yes, definitely. So our fundamental data model is based on DCAT and schema.org. And JSON LD and this way of integrating with this is based on the same ontologies basically. Stack 2 is also very compatible as we saw in my presentation with our way of organizing these catalogs. But instead of creating a stack implementation, we aim to do this using a form of compatibility layer in order to facilitate the platform aspects of our platform to enable self-service data uploads and these kind of things, and have users be part of the data sets that we can offer on our platform, either for free or maybe with time monetized as well.
Okay, sounds good. And Maysam, we gave you time enough to raise your hand. Maysam, the floor is yours.
Yeah. Hello. Can you hear me?
Yes, we can hear you, Maysam. Hello.
Yeah, I just first of all thank you for your interesting webinar. I just have a kind question. What do you think, or do you think it's will be possible in the future to connect all the platforms we have, or what do you think about the future step of launching the platform or digitalization on the ocean? And in this case, do you think what we need in this case as a future case? Hello.
Yeah, maybe I can share my 2 cents. So basically, the way I definitely think it's possible through standardization and stack and decat ontologies is definitely 2 ways of achieving this. I think that Otis, for example, has a very, very good initiative going towards this goal, enabling discoverability across platforms. And I also think that the way that Pangeo and Microsoft Blender Computer expose their data using Stack and then allowing catalogs to interconnect is also a very very cool initiative. So this is definitely possible.
Thank you.
Tom, did you want to add something to that or no?
I wouldn't add it. I couldn't add anything.
Yeah, so what we try to achieve with this digital twin, so the approach in Iliad anyway, is to make our solutions, the twins, what you call agnostic, so technology agnostic, and to do our best, to contribute to the interoperability between platforms. So since we have several platforms already inside Iliad, we are, in a position to experiment with this, making this interoperable and exchangeable. So reusability, as you know, is and that's is one of the key keywords. Yeah.
Yes, I agree.
And there's lots of different resources, but I think that we've mentioned the my mind's gone blank because there's too many acronyms going on. The Otis approach, and then there's also related to that, there's the Ditto program at the UN level, which has very close links to that. More on digital twins of the ocean, but the 2 are very connected.
Yes.
I don't think I'm using that. Yeah.
Any more questions? No. And meanwhile, Bente can ask more. So we got a very nice overview and a little bit also detailed information. But in order to get really started, I guess, are there, what is the step-by-step way for users of the Ocean Data Platform? Do you have any more material? Will it be more material in the coming days that we can make available on the Hackathon page, etc.?
So what I was going to propose, and this is something which I've already done through the when we've sent out the forms to people signing up for identifying teams and joining the hackathon. We've asked who would be interested in testing out different Iliad components, and one of them was the Ocean Data Platform. So I think it's going to be summer in Norway now for July, so a lot of the Norwegians are going to be off, including our team. So I think in August, as we start to prepare for the hackathon, do the virtual work on the hackathon, building towards a physical event in September, we'll probably organize a more in-depth sort of user session for the Ocean Data Platform and give people access who are interested in testing out the platform in the context of the hackathon. So I think that's probably that would be the next step for engaging people with using the platform and testing the platform out.
Okay, thank you. I'll follow up. And Jeremy, welcome, and unmute yourself. I'll give you the floor.
Hey, yeah, just real quick question. So great presentation. Thanks for sharing what you've been working on. And I think this is super valuable for a lot of different verticals. One of the issues that often comes up, especially we're obviously pretty heavy I'm with OC and AI, and most of what we're doing is training machine learning models. when you the old saying garbage in garbage out plays true in this scenario, and obviously we've had our first hallucinations early on when we first started, one of which is our LLM decided to call himself Seaweed Steve, which was a little creepy. But when we look at data that's coming through, I mean, we were getting a lot of different data sources as well. One of our challenges has been, really quantifying and qualifying accurate data sets to make sure that, it's something that can be usable, because the second that you provide a data supply to someone and saying, hey, this is the truth, and if that data comes in as garbage, it really ruins your reputation pretty quickly. So what metrics are you putting in place to ensure that especially when it comes to environmental impact and also risk assessments? What are you using to verify these data sets? Is it consensus based? I'll just be curious. Thanks.
Before you answer, Jeremy, thank you very much for that question. When you are saying we, I see Texas, Mr. Ocean, and a little bit of NASA on you. Which organization are you
Well, we work with a
representing?
bunch of data partners as well. And I'm a character in a comic book series called the Ocean Defenders. They use my likeness, me and Richard Branson and a few other characters. That's where the Mr. Ocean comes from.
Okay.
But I also host an event every year on Sir Richard Branson's island called Ultramarine, where we bring everyone ocean related together to try to solve the world's biggest challenges.
Okay, so interesting. Happy to have you here. And now I leave the floor to Thomas and Tom to answer. And I have a follow-up for you, Jeremy. So Thomas, Tom, you wanna?
I can sort of go first. So
Yeah.
certainly the data that we put into our catalog, public facing catalog, we kind of quality control ourselves. And we have a team of sort of data engineers and sort of subject matter experts that kind of verify that data before it goes there. So it's the ambition, the long-term ambition around people being able to share their own data into the platform and make that available through the catalog is there. But of course, those questions around quality are very present in our minds when we're thinking about that. So it's why we haven't implemented a feature that allows you, like general users, just to be able to share data into the catalog. To your point around sort of training data for AIs, I think that's probably one of the main reasons why, and Thomas, you can correct me if I'm wrong, and probably will. One of the main reasons why we focused on designing the tabular API storage controller first, thinking that having that kind of structure in place that would be able to support machine learning and AI applications is kind of the direction of travel for a lot of data types. And so that's why we put a lot of effort into supporting tabular before thinking about how we would consider raster and gridded data and other data types through that API. But like that's on our minds. Just wanted to reference one of the other webinars that we organized 2 or 3 weeks ago, where we talked about LLMs and machine learning and things like this. We have a company that's situated just right next to us called Cognite. They work on industrial data platforms and digital twins, and they have a lot of focus on integrating LLM technologies for natural language queries for their digital twins. And of course, because they're dealing with safety and operations, they have a real strong focus on avoiding not having hallucinations. So you might want to have a look at that webinar. I think it's on our YouTube channel for this Iliad project. So I'm happy to send you a link to that. But definitely it's we haven't got any AI integrations on Ocean Data Platform yet, and part of the reason is because we had a ton of other stuff to do, but another reason is because we don't just want to put something on there that's not thought through and is going to start hallucinating. So I think those are such good questions, and happy to take a conversation offline about that.
Yeah, no, great. Thanks for answering that. Yeah, I mean, we had a lot of those problems, I would say 6 years ago, but those problems have ceased to exist for the most part. I mean, it was cute when it said, "Hi, what's your name?" And it says, "My name is Seaweed Steve." You're like, "Well, we never put that anywhere." But that was TensorFlow era, right? So things have changed significantly, and so that's helped us. Thank you for that answer. I appreciate it.
Yeah.
Thomas, did you want to add something to Tom's response to Jeremy here?
I think Tom covered it very well, and just to amend that, yeah, we also see that once again, knowledge graphs is also one of the ways of going in this direction. Being a data sharing platform, we also focus on providing the tooling in order to do this in automated or semi-automated fashion. There may be different kind of metrics to provide this kind of data quality measures, and sort of decorating that through, for example, this observable concept that we have is the way that we see this being done at the consumer level scale.
Yeah, I have, so Jeremy, I also have a bit of an ocean background here, and I have two comments to you for the quality. Now, following on what Thomas said immediately, it was this maritime data conference in Bergen a couple of weeks ago, where we were discussing exactly this quality checking. So you can do a lot automatically, but the human factor is always necessary in order to really, you really have to have knowledge about the data, the collection of the data. So the human factor was concluded in this meeting will never go away. So I guess this is for stopping hallucination of artificial intelligence. So this was I believe this is sort of the state of the art recognition that you can do a lot automatically, but you do have to have, for your really good quality data, you need to have the human factor involved. Now, on that, so that, of course, this is related to the artificial intelligence and machine learning aspects, but there is also situations where quality of data is seen from another perspective. So I was involved in developing the tsunami warning system based on, well, first the Indian Ocean and then in the North Atlantic and Europe. And what is specific with that situation is that, well, sometimes you actually, any data is better than none data. And so what normally I say about data quality is that the most important thing is to know the quality. I mean, as long as you have that knowledge, so have that knowledge in the metadata about the data, I think this is the key. And then you know what you are using it for, just to add on to the answer here. And this is what we are trying. I mean, this is what we are trying to do. Use very good data management principles, not even beyond FAIR. And this is one of my babies, by the way, because GEO, this is Earth observations. Go beyond, because we are saying also it should be, of course, FAIR, but we are going further and say it should be open by default. And it's also more addressing the complete life cycle of data, because you have to maintain the data. The repositories have to be maintained. You know, it doesn't stay stable. Huh? so covering the entire life cycle of the data in the data management principle is an added value. And then of course you have the care and trust principles that is, having niches and complementing these principles. So in general, if the message should be have excellent data management. And I guess it's not hard to convince people about this here. Anyways,
Thank you.
I was rambling. I'm very happy to see. It's very exciting that we are, attracting additional communities, right, Tom? I think this is, so please, Jeremy, if you want to be a part of this hackathon, we are building a brand new digital twin for the Oslofjord, by the way, could be cool. And of course, we will use the ocean data platform for that. So this could be an interesting and fun way to play. Okay, any more questions? No. It's like, yeah, you have to You have to drag it out of, maybe it's the shyness or don't be shy. And remember, no question is stupid, huh? Or not comment. Everything is valuable in my view. So please don't be shy. Of course, if you haven't registered yet, you have registered for the hackathon because you are here or in the list of HuBocean, Tom. Is that, yeah?
Yeah, so I think most people have, of course. If you haven't registered, then reach out to me. I think you probably will have either found this on LinkedIn or through one of the emails that we sent out in relation to the hackathon. So if you haven't signed up and you would like to be a part of it, then just send me a message and we can see how best to include you.
Exactly. Because the deadline, if you look at the web page, it looks like the deadline is passed. It is, but since you are here, it's still open. So, yeah.
I have another question if you want. If you
Yes,
want a
yes.
question.
Yes, of course.
One of the challenges that I've had to deal with in times past when pulling in a mother of different collections is that the time variance and the latency. So in some cases, the way people measure time in their data sets are different. So we had to develop a new measurement of time to be able to create segments so that we could actually, I wouldn't call it synchronized, but it was a method of trying to figure out how to best correlate data that were at least on the same plane. Is there any kind of consideration for this on HuBocean?
On HuBocean?
That's a really good question. Don't have an answer to it now. I could ask our data team how they're considering that. At the moment, I think because we've been sort of just taking data that already has a timestamp to it, we've just been using what's there. But that's a good question. That I don't have an answer to. I don't know Thomas would either.
No, it's like you said, we're both basically ingesting data with an existing timestamp, basically.
Yeah. So I can add to that, Jeremy, also, because I'm also a member of OGC, the Open Geospatial Consortium. And actually, it was a whole session of addressing this issue. It was a meeting now in Montreal, but the other meeting before that, it was a session exactly on the issue of time. So perhaps Tom and Thomas, probably I should find those presentations. Could be interesting for you platform and then we can share it also as part of the hackathon material. This is open from OGC, so yeah, it's being addressed. It turns very philosophical in the end, actually.
Well, I mean, yes, philosophically, yes, of course. Time is a variant depending on where the observer is. But I think that, when you have sensors in the ocean that operate at different hertz, different ratings, then you're going to get kind of overlaps in multiple different sectors. And so sometimes it's better to just create a block and say, this is the data that was collected in this block, and let's try to synchronize as best as possible. But I think, it would just be interesting to see, ways to kind of incorporate HuBocean into some stuff that we're doing. I mean, I can only speak for the stuff that I've got experience on. So, but no, thanks for answering.
Yeah, no, I will. That's a good point. So Thomas, there is a material on that level of detail as you described, Jeremy. Even I cannot talk very intelligently about it in detail, but I do know I was attending the presentations. So there are material, and there's a small group actually that work on that issue. So connecting you with them, I think, could be valuable.
Cool, thank you.
Okay. Right. I guess we are full. We have had a very nice presentation and also a very interesting discussion. Thank you very much for participating, both in the polls and in the questions. And do contact us if you're not yet signed up for the hackathon. please do. And you will see there are many of the topics that we discussed today that will be addressed in the hackathon. Okay?
Thank you
Thank
for
you very
moderating,
much.
Bente.
Thanks.